right, so we're going to be working with a two resistor circuit here, and in this case we've got two resistors. Both resistors are 1 kilo ohm of resistance. All right, and so I've got my power supply is set up for 5 volts. And what we're going to do is we're going to just look at this circuit. But before we do that, let's just kind of review Ohm's Law. Remember, Ohm's Law tells us that the voltage is equal to the current times the resistance. We're doing DC, so we'll use capital letters. Voltage is the current times the resistance. And also the power law, which tells us that the power is the voltage times the current. All right, so here we're going to be using two 1 kilo ohm resistors in series. And we're going to use our power supply is going to be set to 5 volts. And we want to measure the current. And we're going to measure the voltage across each resistor. And look at measuring the current in different places within this circuit. Now, using Ohm's law, we know that the voltage is equal to the current times the resistance. And we know that the power also is equal to the voltage times the current. So if I have a 5 volt supply and I have two resistors in series, notice that when these two resistors are in series, the current flowing through the first resistor this first resistor also has to flow through the second resistor. So that current has two resistances to go through. So if each resistor is 1K, both resistors together is going to be 2K or 2,000 ohms. So therefore, my total current is going to be 5 volts divided by 2,000 ohms. So the total current is going to be 250 milliamps. Right? So if we use Ohm's law again, we can calculate that the voltage drop across this first resistor is going to be 2.5 volts. And the voltage drop across the second resistor is going to be 2.5 volts because this is a 1K resistor. It's got 2.5 milliamps going through it. So Ohm's law tells me it's going to drop 2.5 volts. So notice we've got 5 volts total, and we're going to drop half of that voltage across this resistor and half across this resistor. Now that is because both resistors are the exact same size. So let's go ahead and connect up the circuit and see how it works. Alright, so here are my two resistors. These are both 1K ohm resistors. This is a 2 watt resistor, and this is a 1/4 watt resistor, but both of them have brown, black, and red as the first 3 colors bands, and so therefore there is, each one is 1,000 ohms, give or take their tolerance amount. And we've measured those before in a different video. I'm not going to measure them here. But so I'm going to take my power supply. I've already actually set the power supply to 5 volts. You see the display says 5.1, but again, the display on the power supply is not a calibrated value. It's just a reference point. So you always want to use a meter to measure the actual voltage. So I'm going to take this, I'm going to hook this, come out of my positive, come out of the positive here into the top resistor. I'm going to use a jumper. grab a jumper here. I'm going to use a jumper, and I'm going to jumper these two together, separate them a little bit further, and then I'm going to come out of the bottom resistor back into my power supply. So the power supply is on, it's got 5 volts, so I have current flowing through there. So now if I take my meter, I take my voltmeter here, and if I measure from the top to the bottom, I get 5 volts. If I measure across one resistor, I get 2.5. Notice this is like about 2.58 here. The larger resistor is a 2-watt resistor, but its resistance actually turned out to be a little over 1,000 ohms. And the resistor over here turned out to be slightly less than that. So notice I'm getting 2.4 there and 2.58 there. So notice if we add that up, 2.42 plus 2.58, and you add those up together, you're going to be at 5 volts. That's actually Kirchhoff's voltage law. The sum of the voltages are the sum of the supply voltages is equal to the sum of the voltage drops, or the sum of the voltage around a loop is 0. So as we go up, we're going from ground up to the power supply here. Here's my power supply, this whole red up here at the top, or actually on the left of your screen there. And so that's 5 volts, and then I'm dropping 2.42 volts across this 1K resistor, and I'm dropping 2.58 across this lower resistor. And so again, those add up to the supply voltage. All right, if I want to measure the current, to measure the current in a circuit, you have to stick the current meter in the circuit. And so the current meter, you have 2 connections, right? You've got a positive and a negative on your current meter. So you basically need to remove a wire. So I'm going to take this jumper right in the middle. I'm going to remove this jumper, both ends of the jumper. I just removed both ends of the jumper, and I'm going to take those now, and I'm going to put the current meter here, and you can see now that it's measuring 2.44 milliamps. All right, so we were expecting 2.5 milliamps, so we're definitely, within a couple of percent of where we should be. Remember, our original circuit in the book, had 1K resistors, but our 1K resistors, one was slightly above 1K and one was slightly below, but so the value may not be completely accurate. All right, so but again, to measure that current, I had to break the connection. So I had totally removed this jumper and broke that connection. Now if I want to measure the current if I wanted to measure the current here along this edge, okay, then I need to break this connection. All right, so what I did just measured was this connection right here, and I measured this current. But I just want to verify that the current is the same everywhere in the circuit. So looking at this, they've got this meter here going between the top resistor and the positive. So I'm gonna take, right now I just have a red lead going from positive to the top of this resistor like I'm showing here. I'm going to remove this lead and then put the red lead of the meter into the positive of the supply and the negative into the negative there. And I'm going to measure the current, and it should still be that 2.4 milliamps. And then I'm going to, after I do that, just to show you here on the screen, I'm going to take and I'm going to put the meter down here. And so wherever we put it, it should read the same, but you need to break those connections. So, you basically just need to come along and remove it at 2 points. So you need to kind of break the connection at 2 points like that, and then you can stick in the meter. Alright, so we already broke the connection here in the middle with this jumper, but now I'm gonna take my power lead out of the power supply and disconnect it from the top resistor. And then I'm going to stick the positive of my meter. Again, it's got this alligator clip here, and one of the ends is smaller than the other. That smaller end will just fit right in there. So I'm going to come out of my positive of the power right up here into the 100A, 100 milliamp, 100 mA connection on the bottom of the meter there. Come out of the black ground connection and connect to the top resistor, and again we can see that 2.44 milliamps. Then I'm going to take the meter out one more time. I'm going to replace my positive lead. So I'm going to put the positive lead in here. And then I'm going to disconnect and remove. I'm going to totally remove the ground lead. All right, so when you are trying to measure current, you definitely want to remove a wire. So I'm going to connect the positive to the bottom of the resistor, and then I'm going to put the alligator clamp here. And again, we can see the current is reading 2.44 milliamps. So we're reading 2.44 milliamps no matter where in the circuit we inserted the meter. So inside of a series circuit or a series branch, the current is always the same.